Microchips are everywhere. With technology advancing rapidly, the demand for high-efficiency microchips is growing. Though they may seem trivial, these tiny components are vital to modern electronics. Curious about how they're made? We'll break it down in this video. Today, we're diving into the fascinating world of microchips. What is a microchip? A microchip is a silicon disk embedded with integrated circuits and transistors. These tiny switches are arranged in complex patterns on a silicon wafer, creating a detailed lattice of interconnected shapes that are crucial for the chip's functionality. Raw material, silicon, often called digital gold, is a fundamental material in the tech industry. It's a widely used semiconductor whose properties are enhanced by adding elements like phosphorus or boron. Silicon is derived from sand, which is the second most abundant element on Earth. Silicon dioxide is melted into a large cylinder called an ingot, and thin wafers are sliced from this ingot to form the base for microchips. Why silicon? Silicon is a semiconductor, meaning it can conduct electricity under specific conditions. Each silicon atom has 4 outer electrons, making pure silicon non-conductive at room temperature. By introducing small amounts of atoms like boron or phosphorus, a process known as doping, silicon's conductivity is improved. The transistors on a chip consist of p-type and n-type layers, which manage electric currents. How are microchips made? Step 1. Layout and design. Designing microchips is a highly intricate process involving billions of interconnected transistors. The layout determines the chip's technical and physical properties. A detailed three-dimensional blueprint of the chip is created and transferred onto photomasks, which act as templates during fabrication. Step 2. The clean room process. Microchips are manufactured in ultra-clean rooms with strict air quality standards. The wafer surface is oxidized at approximately 1,000 degrees Celsius to create a non-conductive layer. A light-sensitive photoresist is applied, then exposed to light through a photomask, transferring detailed patterns onto the wafer. Step 3. Doping process. Doping introduces impurity atoms like phosphorus into the silicon to alter its conductivity. This process is repeated to add layers and connections, enhancing the chip's functionality. After doping, the wafer undergoes further oxidation. Polysilicon is deposited on the insulation layer, and the photoresist is applied again and exposed to light through the mask. Step 4. Smooth finishing. The wafer is polished using a chemical-mechanical process to ensure a smooth finish. After several steps, the wafer contains numerous individual chips, which are cut with precise scribe lines for accuracy. Quality control involves inspecting the chips with scanning electron microscopes. Step 5. Assembly. In the final stage, individual chips are mounted onto packages and connected to terminals. These chips are used in various devices, including smartphones and electric cars. Semiconductors are also created for high-power applications like trains, solar panels, and wind turbines. Proper cooling systems are integrated into the packages to manage heat. And that's a wrap on how microchips are made. Do you know more about the microchip manufacturing process? Have you ever seen a microchip? Let us know in the comments.